Hello dear students, this is Asif Javed. Once again, first of all, I would like to apologize from the very core of my heart that I could not make myself available for you guys for quite some time. There has been a long gap in between, so apology on my part, but I will make sure that the subsequent videos arrive to you guys in time. So this is going to be the lecture number 2 as far as your set exam is concerned. We had done some questions, and in this lecture we will take some more questions. Let me take this one first. This, if you see carefully at this question, this is from the concept of continuity. So I would like to tell you what we have to do in this question. See, you have been given a function and you have to comment whether this function is continuous at 0, discontinuous at 0, whether this has removable discontinuity continuity at 0 or B but not C. So let's see what's going to happen in this case. So the question reads this. Let me choose the color of my discretion. Is it possible to do so? If not, then I am going to continue. Here is the function. Oh my god, I can choose the color. Just a second. So let me choose, now this is the function f of x. Yes, I can choose color of my choice. Let me choose this color. This is a bit dark. Let me increase the size of the font. Okay. So f of x is equal to sine x by x if x is not equal to 0, and this is equal to 1 if x is equal to 0. So for the continuity of function, we know one thing, that left hand limit should be equal to right hand limit, and that should be equal to the value of the function at that point. So if we look at this function carefully, one thing is very much clear to us, that both left hand limit and right hand limit, if you calculate for this function, both of them are going to be 1. And if you look at the value of the function at 0, that is also equal to 1. That means left hand limit or right hand limit both exist at 0, both are equal to 1, and this is also equal to the value of the function at 0, which is given to be 1. So one thing is very much clear, that this function is continuous. So what we can say is that this function is continuous at 0. So discontinuity, we cannot tick this option. It has a removable discontinuity at 0. This is also wrong. So which option is going to be correct? D option says B but not C. No, B option is not correct, because this function is continuous at 0. So D option is also not correct. C option is not correct, because this function is continuous. So how can we say that it has a removable discontinuity at 0? So the right option for this question will be the right option is going to be the option number A, that is, this function is continuous at 0. This is a very nice function. You can play around this function. If you look carefully at the function f of x, suppose I do a bit of modification in this function. This is sine x by x, x is not equal to 0, and if I write anything other than 1 here, suppose I write any c where c is not equal to 1 at x equal to 0, then this function will be having a removable discontinuity at 0. If I place anything other than 1 at x equal to 0, then this function will be having a removable discontinuity. So if this function can have a twist, then this is the maximum twist that examiner can put in this very question. So this is all we have from question number 6. Let's come to the next question. I suppose this is quite clear to one and all. Let me come to this question. This question may seem threatening to you guys at the first instant, but this isn't. You must have come across a very important concept of series, and in case of series we have a ratio test. What is that? Limit n approaches to infinity, we calculate a n plus 1 upon a n. Now if this limit is lesser than 1, then we say that the series converges. If this is greater than 1, we say that series diverges. But unfortunately, if this limit comes out to be equal to 1, then the ratio test fails and we have to look elsewhere. So let's hope that we get less than 1 or greater than 1. That will be sufficient enough for us to conclude whether this this series is convergent or not. So let's see what is a n here. So a n is equal to 1 upon n factorial. From a n we can calculate a n plus 1. This is equal to 1 upon n plus 1 factorial. So let me calculate limit, if you don't mind. Let me calculate limit n approaches to infinity a n plus 1 upon a n. If I calculate this, what I am going to get is limit n approaches to infinity. This is 1 upon n plus 1 factorial upon 1 upon n factorial. So n factorial goes up, and I can further write it as limit n approaches to infinity. Since what we have in denominator is n plus 1 factorial, so it will get cleared up by factorial n factorial. So we will be having n plus 1 in the denominator. So this will reduce to 1 upon n plus 1. So as n approaches to infinity, this whole goes to 0. So that means this limit is equal to 0, which is lesser than 1. And whenever this limit is lesser than 1, then the series converges. So therefore we can say that this series is convergent series. You must be able to see, as I am taking the screen recording, it's already 8 to 12, it's midnight. So I am going to get some sleep now. So I am going to conclude video shortly this time. Next time I will make a bit long and will try to cover as many questions as I can. Up till then, this is Asif Javed signing off. Thank you so much.